Yesterday morning, a magnitude 7.8 earthquake ripped through the southern Philippines, collapsing a school, killing dozens, and sending a tsunami onto the coast of Mindanao. But the quake itself is not the story today. In the first morning alone, that fault produced 138 aftershocks, 3 of them above magnitude 6, and the scientists who watch it are warning that the next 48 hours carry the highest risk. By the end of this video, you will understand exactly what they are watching for and why they refuse to call this over. Yesterday morning, at 37 minutes past 7 local time, the seafloor off the southern coast of Mindanao in the Philippines ruptured in a magnitude 7.8 earthquake. It was the strongest earthquake to hit the Philippines all year. It collapsed buildings, including a school. It killed dozens of people. It sent a tsunami onto the shore. And here's the part that matters most today, the part the early headlines mostly skipped. It is not over. In the first morning alone, the region was hit by 138 aftershocks, 3 of them above magnitude 6. And the scientists who watch this fault are warning that the next 48 hours carry real, elevated danger. So let me give you the facts, fast, and then tell you exactly why the next 2 days are the part to watch. The rupture happened at a shallow depth, about 25 kilometers down, off Sarangani province, just south of the city of General Santos. The United States Geological Survey put the magnitude at 7.8, though the very first automated readings ran as high as 8.2 before the number was refined. Hold that detail, because the shrinking number caused a lot of confusion, and I will explain what actually happened with it in a minute. Shallow is the key word for the damage. The shallower an earthquake is, the less rock there is to absorb the shaking before it reaches the surface. So a shallow quake hits the people above it much harder than a deep one of the same size. At 25 kilometers, this rupture delivered what seismologists rate as intensity 8, shaking in the worst hit areas. That is the level where even well-built structures take damage and older masonry buildings start to fail. And in southern Mindanao, that is exactly what happened. It helps to understand what kind of fault this is, because it explains the danger. Off the southwestern coast of Mindanao, 2 huge pieces of the Earth's crust are colliding. The Philippine Sea Plate is being forced down beneath the Sunda Plate along the Cotabato Trench, and that boundary is closing at about 7.3 centimeters a year. That is fast, as these things go. And fast convergence means strain piles up quickly and has to be released in earthquakes. Subduction zones like this one are the only places on Earth that produce the truly giant quakes. Every earthquake above magnitude 9 in recorded history happened on a subduction zone. So when this fault let go yesterday, it was doing exactly what this kind of boundary does. And the shallow, fast rupture is why southern Mindanao felt the full force of it. In General Santos City, buildings came down. A well-known fast food restaurant collapsed on camera, folding in on itself while people on the street dropped to their knees and power lines whipped overhead. An airport building suffered serious interior damage, with ceiling material crashing into the concourse. A shopping mall shed its facade. A multi-level parking structure rained down concrete and machinery. Roads cracked open. And most of those injuries and deaths follow a brutal pattern that repeats in earthquakes across the developing world. It is not the shaking itself that kills people. It is the buildings, especially older, unreinforced masonry that cannot flex with the ground and simply cracks and falls. The deadliest single event was a landslide. In Sarangani province, the shaking destabilized the slope, and the earth came down, killing 13 people in one place. That is nearly half of the confirmed death toll from a single landslide, a reminder that an earthquake does not only threaten you through buildings. It reshapes the land itself, turning hillsides into avalanches. By the time the reporting settled, at least 32 to 35 people were confirmed dead, with more than 100 injured, and those numbers were still climbing as rescuers reached areas that had been cut off. The president of the Philippines ordered national agencies to respond immediately, and in at least one collapsed building in General Santos, rescue teams were going into the wreckage while the aftershocks were still coming, which is about as dangerous as rescue work gets. There was one piece of footage that captured both the terror and the preparation. At an elementary school in the Davao region, a flag-raising ceremony was underway on the first day of classes, when the ground began to roll. You can see the children drop. You can hear the rising growl of the quake, and then a building fails, and the panic breaks loose. But the teachers, drilled for exactly this, get the kids back under control fast, keeping them down and away from the walls. Remember that image, because it is going to matter when we compare this quake to one that hit the very same fault 50 years ago. There was a tsunami, and it was confirmed, not just warned. When a subduction earthquake thrusts the seafloor upward, it shoves the entire column of water above it, and that water races outward as a wave. The largest measured wave from this quake was about 1 meter, roughly 3.3 feet, recorded at stations in Sultan Kudarat and Sarangani, the provinces closest to the rupture. Smaller waves hit Davao, parts of Indonesia, and as far away as Palau. The Philippine Seismology Agency reported tsunami waves reaching 6 separate coastal areas, and the Pacific Tsunami Warning Center had warned that waves up to 3 meters were possible on some Philippine coasts. Now, a 1-meter tsunami is not the towering wall of disaster movies, but it can absolutely kill you. It is not the height, it is the mass and the momentum. A tsunami is not a wave that crashes once and recedes. It is the leading edge of an enormous volume of moving water that keeps coming, with the whole ocean behind it, and it carries debris that batters anyone caught in it, and it arrives in a series. Eyewitness video from the General Santos area showed water surging in thick with wreckage, then a second wave following behind. The most lethal mistake in any tsunami is to go back to the shore after the first wave, because the second or third can be larger. Here is the detail that shows how far this quake reached. It was large enough to put United States territory on a tsunami alert. The Pacific Tsunami Warning Center issued a tsunami advisory for Guam and the Commonwealth of the Northern Mariana Islands, both U.S. jurisdictions thousands of kilometers across the Pacific. The projected threat there was minor, sea level changes of about a foot and strong currents, and the advisory was canceled roughly 2 hours later once the data came in. There was no threat to Hawaii, Alaska, or the West Coast. But the fact that a quake off Mindanao reached the point of putting American soil on a tsunami advisory tells you the scale of energy we are talking about. A magnitude 7.8 on a subduction zone does not respect distance. So why am I telling you the next 48 hours are critical when the tsunami threat has passed and the Guam advisory is canceled? Because of the number almost no one led with. By 11 o'clock yesterday morning, just a few hours after the main shock, the Philippine Seismology Agency had recorded 138 aftershocks. They ranged from tiny tremors up to a magnitude 6.7. Within the first 90 minutes, the USGS had already logged aftershocks of magnitude 6.5, 6.0, and another 6.0, followed by a steady run of magnitude 5 events just south of Sarangani. Do not let the word aftershock fool you. A magnitude 6 earthquake, on its own, is a serious and potentially deadly event. There are countries that have lost thousands of people to a single magnitude 6. To have 3 or more of them strike the same already devastated region within hours is not a footnote. It is a second and third and fourth assault on buildings that are already cracked, already weakened, already half collapsed. Every one of those aftershocks is a fresh test that some damaged structure is going to fail, which is exactly why those rescue workers in General Santos were in such danger, and exactly why people whose homes are cracked are being told not to go back inside. It is worth understanding why a single great earthquake spawns so many aftershocks in the first place. When the main shock slipped, it did not just relieve stress. It violently rearranged the stress across an enormous volume of rock around the rupture, pushing countless smaller faults and fractures past their own breaking points. Every one of those smaller failures is an aftershock, the disturbed crust groaning its way toward a new arrangement. The bigger the main shock, the larger the disturbed volume, and the longer and more energetic the aftershock sequence. 138 aftershocks in a morning is not a surprise after a 7.8. It is the sound of a vast region of broken rock resettling. There was even a moment that showed how violent this sequence is. After one of the large aftershocks, around magnitude 6.5, a Philippine seismic monitoring station went offline. The instrument, whose job was to watch the earthquake, was knocked out in the middle of the sequence it was meant to record. and the official guidance from the Philippine seismologists was blunt. Aftershocks are expected near the epicenter, and they will continue not for hours, but for days, and potentially weeks. The danger is not in the past tense. It is in the present and the near future, which raises the question scientists are actually wrestling with right now. When a big earthquake is followed by a swarm of smaller ones, there are two very different stories that can be unfolding. And in the first days, they can look almost identical. In the first story, the most common by far, the big quake was the main shock. It released the strain, and the aftershocks are the crust settling, getting smaller and less frequent until the danger fades. In the second story, the rare one, the big quake was a foreshock, and what looks like aftershocks is actually the fault building towards something even larger. We are not inventing that fear. The world watched the second story play out. In March of 2011, off the coast of Japan, a magnitude 7.3 earthquake struck. 2 days later, the same fault zone unleashed a magnitude 9.0, the Tohoku quake, that killed close to 20,000 people. That 7.3 had been a foreshock, recognized only in hindsight. It happened again more recently, when a magnitude 7.4 near Kamchatka in 2025 was followed by a magnitude 8.8. So no responsible scientist will stand up in the first days after a 7.8 and promise the worst is over. But, and this is the crucial part, raising that possibility is not the same as predicting it. Only a small percentage of large earthquakes turn out to be foreshocks. The vast majority are main shocks, and the data from Mindanao points firmly to the ordinary story. Here is how scientists actually read it, using two rules built from more than a century of earthquake records. The first is called Bath's Law, and it says the largest aftershock tends to land about 1.1 to 1.2 magnitude units below the main shock. For a 7.8, that predicts a biggest aftershock around magnitude 6.6 to 6.8. The largest aftershocks recorded in Mindanao were about 6.5 to 6.7, sitting right where the law says they should. If they were creeping upward toward the main shock instead, that would be the alarm signal. They are not. That is reassuring. The second rule is Omori's law, and it governs timing. Aftershocks are most frequent right after the main shock, then their rate drops off, roughly in proportion to 1 over the time elapsed. In plain terms, the first day has the most aftershocks, the next day has fewer, and a week out, the rate has fallen sharply. That is exactly where the danger window comes from. The first couple of days are when a large, damaging aftershock is most likely, which is why, now that one day has already passed, the next roughly 48 hours are the critical stretch. After that, if the sequence keeps decaying the way it should, the risk recedes. To understand what this trench is capable of, you have to go back to 1976. On the 17th of August that year, the Cotabato Trench, the exact same fault that ruptured yesterday, produced a magnitude 7.9 earthquake. For all practical purposes, the same size as this one. It is known as the Moro Gulf earthquake, and it was one of the deadliest disasters in Philippine history. The killer was the tsunami. It swept across roughly 700 kilometers of coastline, struck in the dead of night with no warning, and killed thousands of people, with estimates commonly running between 5,000 and 8,000 dead or missing. Entire coastal communities were erased. So look at the comparison. Same fault, essentially the same magnitude. In 1976, thousands dead. Yesterday, dozens. Why the staggering difference? Part of it is physical. The size of a tsunami depends on the exact depth and geometry of the rupture, and the 1976 event was configured to generate a far larger and more lethal wave than this one. But part of it is entirely human. In 1976, there was no real tsunami warning system here. No network of gauges, no culture of public preparedness. The wave came in the dark and found people defenseless. Yesterday, the warning center was calculating wave arrival times within minutes, issuing advisories as far as Guam, and the public largely knew what to do. Remember those drilled school children? That 50-year difference in warning and preparation is in large part why the same fault at the same magnitude killed thousands then and dozens now. There is one more piece of context worth knowing. Within about 300 kilometers of yesterday's rupture, the historical record holds roughly 35 earthquakes of magnitude, 7 or greater, the largest an 8.3 back in 1918. This is not a quiet boundary that suddenly woke up. It is one of the most chronically dangerous stretches of fault on the planet. And earlier this year, it had already produced a swarm of smaller quakes that closed schools and offices in the region. That comparison does two things. It shows you the ceiling, the worst this trench has actually produced, which is why scientists refuse to relax. And it shows you that the outcome of an earthquake is not fixed by the earthquake alone. It is shaped by depth, by geometry, by warning, and by preparation. The Cotabato Trench dealt a far gentler hand yesterday than it did in 1976, but it is the same fault, and it has not lost a single one of its cards. Before we look ahead, two things worth clearing up fast. First, that magnitude number that dropped from 8.2 to 7.8, to a lot of people that look like someone shrinking the disaster, it is not. The magnitude of a great earthquake is genuinely hard to measure in the first minutes, and the early automated estimates are known to overshoot for the biggest events. The true size only becomes clear once stations worldwide have recorded the full rupture, and analysts have reviewed it, which takes time. The direction of the revision depends on the data, not on politics. And you cannot hide an earthquake felt by millions and recorded on tide gauges across an ocean. There is no cover-up. The Earth already told everyone. And while we are on the subject of viral claims, there is one going around connecting this earthquake to a solar storm that was forecast for the same day. There is no mechanism for that. A geomagnetic storm deposits its energy in the upper atmosphere, hundreds of kilometers up, while an earthquake is driven by stress in solid rock kilometers down, and the energy scales are mismatched by orders of magnitude. Studies looking for a link find no reliable correlation. Two dramatic events on the same day on a very active planet is coincidence, not cause. The second thing scientists are watching is the neighbors. A magnitude 7.8 does not just affect its own fault. It redistributes stress onto the surrounding crust, and that can push a neighboring fault closer to its own rupture. The faults to watch around Mindanao are the Philippine Trench to the east, the Manila Trench to the northwest, and the tangled Molucca and Celebes collision zone to the south. Scientists model this with a technique called Coulomb stress transfer, mapping which neighbors got loaded. The honest version is bounded. It modestly raises the near-term odds on specific adjacent faults. It does not mean the whole ring of fire is about to go off, because there is no mechanism for one subduction zone to trigger another thousands of kilometers away. The real risk is local, specific, and exactly what the experts are tracking. So here is where it stands and what to watch. The most likely outcome, by a wide margin, is the ordinary one. The 7.8 was the main shock. The aftershock sequence is decaying the way Bath's law and Omori's law say it should. And over the coming days, the aftershocks get fewer and smaller while the region begins to recover. That is what the data points to right now. But the next roughly 48 hours still carry real, elevated risk, and that is not a contradiction. There is a genuine, if modest, chance of another large aftershock in that window, something in the magnitude 6 range or a bit higher, landing on buildings that are already cracked and slopes already loosened. Expected does not mean harmless. A magnitude 6 on top of yesterday's damage could be deadly. And the lowest probability scenario, that this was a foreshock to something larger, cannot be fully ruled out in the first days, even though the data does not support it. That is why scientists are on high alert rather than standing down. What the experts are doing over these next 2 days is concrete. They are checking each new aftershock against the expected ceiling, watching for any sign the sequence is climbing instead of fading. They are watching the rate, making sure it is decaying. They are running the stress models on the neighboring trenches. And on the ground, the guidance is simple. Treat every damaged building as unsafe until it is inspected. Stay alert near the coast, and do not mistake a canceled tsunami advisory for an all clear on the earthquake itself. The headlines have moved on, but the fault has not. We will know a great deal more in 2 or 3 days, when the aftershock rate has either kept decaying, which is the likely case, or done something to change the picture. Until then, southern Mindanao and everyone watching this fault stays on alert.